as a refresher, if I want to evaluate these without graphing, how do we find f of 0? We have to decide, does it go into the first piece or the second piece? We use the first one if x is not 0, and the second one if x is 0. So we do the second one and we just get out 1. When I say f of 1, okay, my options are not equal to 0 or equal to 0. Not equal to 0, so we put it in the first one. So 2 times 1 is 2. If I say f of 2, not 0, so we plug in the 2, and 2 times 2 is 4. So we should be able to evaluate on a piecewise, and that was the first thing on your homework last night. You had just some that you were plugging in and seeing what you got. Then, if I wanted to graph this, what was our strategy for graphing? What did we do? Made a table for each piece. Okay, and we always put in the endpoints. Now the first piece, it says x is not 0. The 0 is kind of like an endpoint. I have to plug it in, but since it's not equal to, how will I show that on my graph?
Open circle.
And then otherwise, x just has to meet this requirement. So we can plug in anything else. We can put in positive 1, we can do negative 1, we can do positive 2, negative 2, as many points as we wanted. If I put in 0, 2 times 0 is 0, so 0, 0 is open. If I put in 1, 2 times 1 is 2. 1, 2. Put in negative 1, 2 times negative 1 is negative 2. So this one, it was for everything except 0, so it kept going in both directions. So we extend that line both ways. All right. The second piece tells me 1 if x equals 0. So the only x value we can plug in is 0, and we get out 1. So 0, 1 is a point on my graph. All right. I didn't have you do it on the homework last night, but I do still want to talk about it on some of our problems. Domains and ranges. So remember, those questions asked for it on the graph, but I told you you didn't have to. If I'm looking at my domain, that's my x values. As I go from left to right, this is hitting everything. Not 0, but the blue dot does hit 0. So my domain hits all x values. My range, if I'm looking at my y values, this hits all the negatives, it stops, and then we hit all the positives. So how would I write my range? Is this graph continuous? No. I can draw this part, but when I get right here, I would have to pick up my pencil to make the dot. So it is not a continuous function. And like we talked about yesterday, a lot of times these piecewise functions are not. Questions on that? Do we need another problem like this? Let's look at one more. We're going to graph this one. Okay, how many different t-charts am I going to need? 3. So the first one, x plus 1 if x is less than or equal to 2. I told you yesterday we have to put in the endpoints, so I have to plug in 2. Will it be open or closed? Closed, and we know that because it has the equal to. And then we need things smaller than 2, so maybe a 1 and a 0. So if I plug that in, 2 plus 1 is 3, 1 plus 1 is 2, 0 plus 1 is 1. 2, 3, 1, 2, 0, 1. So this was my starting point. I was extending it to get these points, everything less than 2. So it goes that way. Okay, the next one. This has 2 endpoints. So I have to do 2 and 4, and we can do something in between. The 2 did not have an equal to, so it will be open, but the 4 did, so it would be a closed circle. Is this one going to extend either direction? No, we have 2 endpoints. We have a starting and a stopping point. No matter what, on those, I'm getting out 3. So 2, 3 is supposed to be open, but I already have a closed circle there. So what do? Keep it closed. 3, 3, and 4, 3. I'm just getting this horizontal line right there. Last one, I have to do x greater than 4. So start with 4 and then things larger. The 4 does not have an equal to, so it would be open. So 2 times negative 2 times 4 is negative 8, plus 7 is negative 1. 5 times negative 2 is negative 10, plus 7 is negative 3. 6 times negative 2 is negative 12, plus 7 is negative 5. 4 negative 1, 5 negative 3, 6 negative 1. So do a T-chart for each piece. Make sure you always plug in those endpoints. Equal to gets closed circle. If it's not equal to, it's an open. Questions? Alright, do we feel okay with those piecewise? So that was last night's handout. Today we are briefly going to talk about one other piecewise function that's called the greatest integer function. So you may or may not have seen this one before. Sometimes she gets to it in Algebra 2 and some years she doesn't, so I don't know if you got to it last year. It has a double bar on the x, and so you can plug in any number you want, but what you get out is an integer. What are integers? Yeah, 1, 2, 3, 0, negative 1, negative 2, negative 3, so positive and negative whole numbers there. If you put in an integer, you get that back out. So if I put in negative 3, I get out negative 3. If you put in a non-integer, so if I said 2.5, we have to ask ourselves, 2.5 falls between what 2 numbers? 2 and 3. It always gives us the smallest one. So I would get back a 2. So if you put in a non-integer, you get an integer out, but it cannot be bigger than what you put in. So for instance, if I asked you to find the greatest integer of negative 3. Negative 3 is an integer, so we get out negative 3. It doesn't change it if you put in an integer value. If I ask for the greatest integer of 1.99, if you think about a number line, 1.99 falls between 1 and 2. You always have to go with the smaller number. So we're going to get out 1. You can't get out bigger than what you put in. If I ask for the greatest integer of negative 4.2, Negative 4.2 falls between negative 4 and negative 5. What's the smaller of those two numbers? So we get out negative 5. So just ask yourself, what two numbers does it fall between? Your answer is the smaller of the two. Alright. Do you guys understand how we evaluated those?
Mhm.
So we're going to do a few examples with graphing. This is not one we'll do a ton of, but I'm going to do maybe 3 or so, and then you'll have a couple on your homework as well. So I just want to first talk about the basic raised integer. And I'm not going to do all that. I'm just going to do domain and range from it. You cannot pick points like we are used to on this. We're used to just plugging in some numbers, like negative 1, 0, and 1. But if I put those in, negative 1 is an integer, so we get out negative 1. 0 is an integer, so we get out 1 is an integer, so we get out 1. And it actually isn't giving us much. Okay, I have 3 points, but I don't really see what's happening in between them, because in the greatest integer changes your numbers when you plug in decimals. So, let's try some. If I put in like 0.5. 0.5 falls in between what two numbers? 0 and 1. We get back the smaller one, so it's still 0. Okay, so I know I have 0, 0. When I'm at 0.5, it's still 0. Would you guys agree anything between 0 and 0.5 is going to give me 0 out? If I put in 0.9, what am I going to get out? 0. So I'm still getting out 0 here. If I put in 0.99, what am I going to get out? 0. We are stuck on this step until I plug in the 1, right? Kind of like when we were graphing our piecewise. You know, this one started at 2. Or let's see. This one started at 4. We couldn't do the first number bigger than 4, so we did 4, but we did an open circle to show that it wasn't equal to. I am stuck on this step all the way until I get to 1. Now when I put in 1, it technically jumps up here. But everything before that, I'm down here at 0. So what we're going to do is put an open circle at 1, 0. Okay, does everyone understand why I put an open circle right there? So the greatest integer is always going to look like stair steps. Because if I put in 1, I get out 1. If you put in 1.5, what are you going to get out? 1. If you put in 1.9, you're getting out 1. So we're stuck here getting 1s until we put in 2. And then once we put in 2, it jumps up here. So we have an open circle underneath it. So our pattern is, it's a closed circle on the left, open circle on the right, and just a horizontal line in between. And in general, when we graph these, we'll make a T-chart to kind of get one step. And then once we know our pattern, we'll just draw some more in. This keeps going forever. You could go down as well. So the step before this would have been below it. So you can extend this as much as you want. My rule of thumb is I want to see at least 3 steps, but you can do more. And then I just usually put dot, dot, dot in both ends to show these steps keep going. My graph didn't just stop. That pattern continues. The domain. What x values does this graph hit? All of them, doesn't it? I'm on this step and I jump up and the next one picks up. So I'm hitting all of my x's. So the domain is named infinity to infinity. The range, what y values do we hit? Well, I hit -2, -1, 0, 1, 2. What do we call those numbers? The integers. We only hit the integers here. We don't hit any of those decimal values. Alright, so that is the basic greatest integer graph. Okay, all the variations of it that we might have are going to look the same. You're going to have your open and closed circles, it'll just be stair steps. I want to graph a couple variations just to practice and make sure we're okay. So if I put in, let's say, greatest integer of x minus 2. And I wanted to graph it. You cannot just plug in integers for this. You are going to have to do some decimals. So I usually start with 0 and then do maybe like 0.5, 0.9, and 1 to try to get a good idea of my graph. Okay, so if I start, the -2, am I subtracting that before or after I do the greatest integer? After, because it's on the outside. So if I put in a 0, I have the greatest integer of 0, which is 0, minus 2 gives me -2. Because I plugged in my 0 and I got an integer in there, I know this is the beginning of a step. So 0, -2. Oops. That is the actual point I got. And since I got that point, it is a closed circle. Okay, if I put in 0.5, I have the greatest integer of 0.5. Then we have to subtract 2. What is the greatest integer of 0.5? 0. 0 minus 2 is still -2. So at 0.5, I'm still at -2. So far we're stuck on this step. If I put in 0.9, what's the greatest integer of 0.9? 0 minus 2. So 0.9, I'm still stuck down here on this step. But when I put in 1, greatest integer of 1 is 1 minus 2 is -1. So 1, -1 is here. What do I need to put below that? An open circle, because I have to finish the step that I was on. Has to be a function, so it has to pass the vertical line test, so you have to have an open and close together. So now I know my pattern. This is where it started. Close on the left, open on the right, jump up 1. So close on the left, open on the right, jump up 1. Close on the left, open on the right, and you can keep going. Here, at least 3 steps. You can go the other way too. Instead of going up, I would go down. But all the steps are going to look the same. They all have the closed and open circles on the same sides. Does everyone understand how I just filled in my other steps after I got the first one? All right, I want to look at another one. I don't want to do that one. Let's say I gave you the greatest integer of 1/30. Do you guys know, did you see any of these last year? They don't come up a lot, but there are places for them if you think about like postage. If you mail a letter, as long as it's under a certain weight, you just buy a single stamp, right? But if you go over that weight, then there's a window that it takes 2 stamps to mail. And then if you go over that, you need a 3rd stamp. That's an example of the greatest integer. All right, let's look at this. Everybody with me here. Can I just plug in 0, 1, 2, 3? No. So I told you a good idea to start with 0, a couple decimals, and then we'll see what happens. If I put in 0, 1/3 times 0 is 0, greatest integer of 0 is 0. Since this is an integer inside, I know this is the beginning of my step, 0, 0. If I put in 0.5, what's 1/3 times 0.5? 1/6. 1/6 falls between 0 and 1, so we're still getting out 0. So we get the smaller one. So at 0.5, I'm still stuck here on the 0. If I put in 0.9, 1/3 times 0.9. What did you say? 0.3. And if you put in 0.3, what's the greatest integer of 0.3? 0, so I'm still stuck at 0. Okay, if I put in 1, what's 1/3 times 1 is 1/3. What's the greatest integer of 1/3? 0. What's going on here? Yeah, we still have the straight line. We haven't found the end of our first step yet. If you think about transformations, when you multiply your x by something, that's a horizontal stretch, so it's stretching our steps out. If I put in a 2, 1/3 times 2 is 2/3. What's the greatest integer of 2/3? 0. So at 2, I'm still stuck here at 0. What would I have to plug in to jump to the next step? I think we get it at 3, because 1/3 times 3 is 1. So that gave me a perfect integer. The greatest integer of 1 is 1. So at 3, I jump up to 1. That means below it, we have to have an open circle to finish the step. So these steps, the 1/3 just stretched it. It's 3 long. So if I want to finish the pattern, we know it's close on the left, open on the right, 3 units long. So I'm going to be stuck on this step until I plug in 6. And then after 6, it would jump up. Or if you want to go backwards, below it would be until -3. So you're welcome to go either direction. Like I said, at least 3 steps on your final graph. All right. Are we okay with that? I want to look at the last problem of the day, I think. Let's look at this scenario. An express mail company charges $20 for a package weighing up to 2 pounds and $2 for each additional pound or fraction of a pound. Let y equals c of x represent the cost to send a package weighing x pounds. Graph it on the interval 0 to 6. So I'm not even asking you to write an equation. We're just drawing a graph here. Oh, that is very crooked. So I'm going to start at 0. Okay, my y-axis, my cost starts at 20. So I'm going to count by 2s. 6, 8, 10. Okay, if I'm trying to draw this graph, can you have a package that weighs absolutely nothing? No. You'll notice my interval started with a parenthesis on my 0, so what kind of circle am I starting with? An open. What is the lowest price I will possibly pay for this? $20. So I'm going to put an open circle at 0, 20. As soon as I walk in with a package, even if it only weighs an ounce, with this company, I am paying that $20. If it weighs 1 full pound, how much are we paying? Still $20. If it weighs exactly 2 pounds, it's still $20. The first 2 pounds, up to 2 pounds, you only pay $20. But as soon as it goes over 2 pounds, what happens to my price? We add $2 onto it. So I can see my steps a little bit flipped. We have the open circle on the left here. So I'm going to start, if it weighs 2 exactly, I'm still down here. But as soon as it goes over, I'll jump up. Now we're paying $22 for each additional pound. So if it weighs 3 pounds, I'm still at $22. But as soon as I go over my 3 pounds, what do I pay? 24. The cost goes up another $2. And we'll stay at that until we get to 4. And then after 4, we would go up to 26 until we get to 5. And after that, we would go up to 28 until we get to 6.
I need Leela and Brennan.
So that one, we weren't writing an equation, we were just drawing a graph. Are there any questions there? So we are done. You have the handout from yesterday, and I'm giving you a second one for today. We have like 25 minutes. You guys have a lot of time. Both handouts are due Monday.